In graph 8.4, we saw that it is at least in principle possible to lower tax rates on workers and get more tax revenue, assuming the workers respond to the lower tax rates by working sufficiently more. We will now investigate whether this is the case for a worker whose tastes for consumption and leisure are quasi-linear in leisure in the same way as they were in graph 8.9. In particular, we're interested in deriving the relationship between tax rates on the horizontal axis and tax revenue on the vertical axis. This relationship often turns out to have an inverse U-shape, and it has become known as the Laffer curve after Arthur Laffer. We can derive this relationship mathematically by solving the utility maximization problem first. Here, we use as the utility function the same one that we used in graph 8.9, c plus 400 times the natural log of leisure. When we solved that problem in graph 8.9, we derived the fact that the optimal consumption bundle for a worker will be the bundle c equal to 60 times the wage minus 400, and leisure equal to 400 divided by the wage. If the worker's before tax wage is 25, and a tax of t is imposed, then the after-tax wage is 25 times 1 minus t. We can plug that into the leisure equation to get that the optimal leisure consumption will be 400 divided by 25 times 1 minus t. How much leisure this worker takes, and thus how much he works, therefore depends on the tax rate. If the tax rate is 73.34%, for instance, then t would be 0.7334. If you plug that into equation 8.12, you get that the leisure hours chosen by the worker will be 60. That's all the leisure hours he has available, which implies that if the tax rate reaches 73.34%, the worker will choose to no longer work. As a result of no longer working, he will pay no taxes, and the tax revenue therefore goes to zero. The tax revenue if the tax is zero is of course also zero, because if there's no tax charged, it doesn't really matter how much the worker works, no tax revenue will be collected. It is in between these two zero tax revenue points that we get the inverse U for the relationship between tax rates and tax revenue, with tax revenue initially increasing in the tax rate, but eventually reaching a peak and decreasing. The peak for our workers' Laffer curve turns out to occur at a tax rate of 48.4%. It's at that point that he pays the most in taxes that we can possibly get out of him. Here's the way we would solve for this peak. We would take equation 8.12 that tells us the worker's optimal leisure choice is a function of the tax rate and subtract it from the leisure endowment of 60 hours. This will give us the number of hours the worker chooses to work as a function of the tax rate. We can then multiply this by t to get tax revenue, and that'll give us the equation for the Laffer curve. To find the peak, we would take the derivative and set it to 0, and then solve for t. In the past, marginal tax rates were relatively high, above 70%, and it was at that point that many economists argued that we were on the wrong side of the Laffer curve, that we could in fact cut tax rates and thereby increase tax revenues. Today, marginal tax rates tend to be much lower, and most economists believe we're on the other side of the Laffer curve. That is to say, it'll no longer be easy to cut tax rates and expect tax revenues to increase. We can also say something about the relationship between the Laffer curve and substitution effects. In our example here, we showed in graph 8.9 that the worker will increase his work effort as a result of the substitution effect when his wage increases. Conversely, he will decrease his work effort as a result of the substitution effect when the wage decreases, as it does when wages are taxed. We also showed in graph 8.9 that there was no further impact on work hours from the wealth effect, In other words, the entire impact on the number of hours worked as wages change for a worker of this kind results from the substitution effect. This furthermore implies that the inverse U-shape of the Laffer curve is entirely due to the substitution effect in our example here. Put differently, if it weren't for the substitution effect, this worker would continue to work exactly the same number of hours as the tax rate on his wages increased. This would imply that as the tax rate increases, there would be nothing to diminish the tax revenues that we collect from this worker. He'd just keep on paying his taxes. This would in turn result in a straight linear relationship for the Laffer curve, which is pictured here as the magenta line. One final point. We said before that most economists believe that marginal tax rates are now at a point where most people are to the left side of the peak of their Laffer curve. That is to say, for most people it's the case that if we lowered their tax rates, we'd probably get less tax revenue. This doesn't, however, take away from one of the important points of the Laffer curve as we depicted it here. In particular, if we ignore substitution effects, we'll tend to overestimate the amount of tax revenue we can collect from individuals. This is because the substitution effect unambiguously points in the direction of less work as the wage falls. Thus, as tax rates increase, the substitution effect will always work in the direction of lowering tax revenues that we can collect from workers. Even if the substitution effect doesn't dominate, it still implies that ignoring the substitution effect will cause us to overestimate the tax revenues we can collect.